It might sound odd at first, but there's a close relationship between trying on clothes and knowing if a sequence of parentheses is valid. Now look at these two expressions. They look similar. They use the same symbols, but one of them breaks.
Cheese Bytes!
We are given a line of parentheses. The question is simple. Is this line well-formed? Every opening parenthesis must be closed, and nothing should close before it's opened. The first thing we tried was counting. Parentheses come in pairs, so we count how many open and how many close. If the numbers match, maybe we are done, and in many cases, we are. When the numbers don't match, the sequence is clearly invalid. If there are more openings than closings, something is missing. If there are more closings than openings, something is extra. But then there's this. Same count, nothing missing, nothing extra, and still completely broken. So counting helps, but it doesn't tell the whole story. Order matters. So instead of counting at the end, we follow the line as it unfolds. We track how many openings are still pending. Closing more than we have opened means the sequence is invalid. If we reach the end and some openings are still pending, the sequence is also invalid. This works well for a single type of parentheses. But what if we have more than one type? We have round parentheses, brackets, and curly braces. It might seem that it works the same way, but look at this one. So order matters and type matters. We can track how many openings of each type are waiting to be closed. With this approach, our previous example is no longer a problem. However, it's easy to find a new issue. We are trying to close a parenthesis when there is still an unclosed bracket. So we need to remember the most recent unclosed opener. Let's use an analogy to make the idea clearer. Think of a changing room. You walk in and you put one t-shirt on, then a sweater, then a jacket. After looking at yourself in the mirror, you start taking your clothes off. You have to take off the jacket first, then the sweater, and then the t-shirt. Let's try a different sequence. T-shirt, sweater, jacket, and it's not possible to take off the sweater before the jacket. The last thing you put on is the first thing you take off. This is exactly how our problem works. Instead of stacking clothes, we stack openings. Each time we see a closing one, it must match the most recent opening. We repeat this until the end, making sure we finish in the same state we started. This pile of symbols is what we call a stack. The last item added to the stack is the first one to be removed. Last in, first out. Let's see how this works in Python code. We start with an empty stack. This is where we keep the parentheses that are still open. In Python, we implement the stack as a list. We also define a mapping from each closing symbol to the opening one it matches. That mapping tells us exactly what we expect to find on the stack when a closing appears. We then go through the input line, one character at a time. If the character is an opening, we push it onto the stack. Otherwise, we treat it as a closing one. We assume the input contains no letters, numbers, or other symbols. At that point, we ask, do we have something to close? If the stack is empty, we stop immediately. If there is something to close, we take the most recent opening. We use pop to get and remove the last item from the stack. We then use the mapping to check if the opening we pop matches the closing we just encountered. If it doesn't match, the sequence is invalid. We repeat this until we reach the end of the line. At the very end, only one thing matters. Did we close everything we opened? The time complexity is linear because we process each character exactly once. The space complexity is also linear in the worst case, as we may need to store every opening if none are closed. That gives us an efficient solution. The key takeaway is simple. With one type of parenthesis, counting works. But with multiple types, we need to remember the order in which they were open. A stack is the perfect data structure for this job. There's another way to solve this. Same idea, different perspective. I'll leave it here. Leave a comment if you can figure out why it works. This was today's Cheese Byte. Remember, the code matters, but the idea comes first.